Now in the last video we have used the train example to understand what's a linked list. Even though not all properties of train confirm with a linked list, it's a good example to understand the concept of linked list. Now in this lecture we will look at differences between linked list and array data structure. Now in the previous section we have discussed arrays, and here we start to discuss different data structure which is linked list. And the point is, arrays technically allow you to do all of the things linked lists do, such as addition, insertion, and removals. And these methods are already available to us in many programming languages. So you might be interested, why would we use a linked list instead of arrays? To answer this question, we will look at the differences between these two data structures. So let's have a linked list and an array side by side to see how they are different in their properties. The first and the most important difference between a linked list and an array is that each element of linked list is an independent object. So this means that if we don't need any node over here, we can delete it and still linked list will exist. But in case of array, these cells over here are not separate objects, so we cannot delete the cell from the array. Of course, we can delete the value of cell, but the cell itself will exist in the memory. So this means that these cells are not independent objects. But in case of linked list, they are independent objects, so we can always remove any node from here and insert any node over here. And the second difference is variable size. This means that in case of linked list, we don't need to define the size when we create it. We can always decrease and increase the number of nodes in the linked list. The size of linked list is not predefined. So here, if we don't need node 4 over here, we can delete it. And if we want to add extra node at the end of this linked list, we can add it easily. So there is no restriction for this. But in case of array, we need to declare the size of array in the memory, which means that we cannot insert new elements to the same array if it is full. So if we reach the capacity of the array, we cannot add any extra element to this array. So the size of array is predefined. So this is one of the limitations in case of array. But in case of linked list, we can add as many as elements that we want. And the final difference is random access. It means that, so accessing an element in the case of array is very efficient. It means that, for example, if we want to access this element over here, we just need to put the array name and the index of this element over here. So we know that in case of array, index starts from 0, so the index of 2 over here will be 2. So by writing array name and the index, we can access this element over here in one-time complexity. But in case of linked list, to access this element over here, we have to iterate through the elements that are located before this element over here. So we cannot access directly to this element over here, so we have to start from head. In the head, we have physical location of first node, so from head we can come to the first node. Then in the first node, we have physical location of second node, so from first node we can come to the second node. So this means that accessing an element in case of linked list is not efficient. So this means that in the worst case, if the number of nodes in the linked list is n, so the accessing of element in case of linked list might take n-time complexity. So given this, arrays are usually preferred for either small data set or the data sets that are not shifted around so often. So here we have learned main differences between linked list and an array. So hopefully you have understood it. Now in the next lecture, we are going to look at different types of linked list. So see you in the next lecture.